Ron Prinn. I'm a professor here at MIT, and I direct MIT's Center for Global Change Science and co-direct its joint program on the science and policy of global change. So I'm an environmental scientist, particular focus on the chemistry of the environment and climate change. Yeah, I came here in 1968 to get my doctoral degree in the chemistry department here, and got that degree in 1971 and joined the faculty at that point. I lead the Advanced Global Atmospheric Gases Experiment, or AGAGE as it's called. This global experiment began in 1978. It has been supported through most of the time since then by the National Aeronautics and Space Administration. In this global network, we measure the levels of all of the major greenhouse gases and ozone depleting gases in real time on site. So in that sense, the network when it began was unique, and it's now getting close to its 40th year in operation. The goal here is to really understand the sources and sinks of these various greenhouse gases and gases like the chlorofluorocarbons that deplete the ozone layer that protects us. So in that sense, we take those measurements and then we take very complex computer models of the circulation of the atmosphere, and by adjusting the sources and sinks in that model, we work it out to agree with the observations that we're taking. And at that point, we have an estimate of sources and sinks for each of the gases that we measure. That's very important for the various treaties, the Montreal Protocol that protects the ozone layer. So we were able to determine the size of the sinks of the chlorofluorocarbons, and were the first to do that accurately enough to be useful for policy making. And similarly, since then, greenhouse gases, purely man-made greenhouse gases, like the hydrofluorocarbons that sit in your air conditioning in your car, and so on. So we are able to determine where they are coming from, what countries, and also what their lifetime is before they get destroyed. Yes, so we do 20 to 36 measurements a day. If one of the stations, for example, is in Ireland, and about 70% of the time we get relatively clean air off the Atlantic Ocean. But 30% of the time we have air that went into Europe and came back out again and went over the station. So the measurements that we know are air that's come across the Atlantic, that's sort of the baseline. And then the air that comes off Europe is polluted. It's got high levels of these man-made gases, and that difference between what went in and what comes out is the basic signal of how much emissions occurred in Europe. And similarly for all of the other stations, there's now 11 of them.